In the previous video, we discussed about DSU, that is disjoint set union. In this video, I'll talk about minimum spanning tree using Kruskal's algorithm, which implements DSU. So, what is a minimum spanning tree? A minimum spanning tree is nothing but it is essentially a tree inside a graph. A graph. So there is a difference between a graph and a tree. A graph is a tree which has cycles. So if I remove the cycles, then we get a tree. This means that if I am taking a tree and I connect the edges and I choose the edges in the tree in such an order that they don't form a cycle, then I get a tree. That is easy. So if I want to construct a spanning tree in a graph, this means a tree that spans the entire graph. This means that the tree visits all the nodes of the graph at least once. Then I have to choose the edges of the graph in such a way that they don't form a cycle. Okay, so because I want to make a minimum spanning tree, I will choose them in ascending order of their weights. This means I will choose the smallest weight, then I will construct an edge in the new tree, then I will choose another one, and if it forms a cycle, I will not take it. So we will use disjoint set union. Let's just start to implement it. T will basically store the sum of the weights. This is another way of representing a graph. Because I want the weights to be arranged in ascending order, or I want some arrangement of the weights, hence I will be using some another representation of a tree. I'll just show it to you. So initializing the parent array, I know. Find parent of x. Right, easy. Now I will be initializing my function void k, that is Kruskal's algorithm. Just look at the way I'm implementing this graph vector, and inside each block there is a pair of weight. This is the weight, and then I've got the node. Node will store an edge from x to y having a weight of type int. Okay, this is my graph, and then I'll get another graph which will store the tree. See, because there is no difference between a tree and a graph. The only difference is that a tree does not have cycles, a graph has cycles. Right. So you can implement them both in the same manner. There is essentially no difference. Right. Now I will traverse this. I will have to sort this tree, this graph, in ascending order of weights. So I will use a function which will take a node and a. You should know how to implement these things. So this is the comparison function that I will use in sorting, and it will return a dot first is less than b dot first. So I'll sort g dot begin comma g dot end comma f. So it is sorted, right? Now the next thing that I will be doing is this function will essentially take a pair of values from this vector and throw it inside this function, and this function will help it sort depending on the first values of this, and the first value is basically the weight. Then what I'm going to take is now edges that have not been I'm going to go through the iterator, and every iterator is basically a pair. So int u will be equal to star it find parent of what? Parent of star it dot second dot x. So the parent of a little bit of error. So the parent of star it, that is the pair of second, I'm taking each edge, so of second, so second is the node dot x. Similarly v is find parent of star it dot second dot y. So we get the parent of the edge x and y. Now if u is not equals to v, this means that on joining this edge, on creating this edge, I am not creating a cycle. Then I say okay, parent of u is equal to parent of v, that is fine. T will be equal to star it dot first, and I can just happily push back star it, right? So I think this is it. So I am taking each and every edge from this graph and finding the parents of the vertices connecting these edges. If these vertices do not form, if their parents are not same, that is, they do not form a cycle, then I make their parents same. I add the sum of the weight to the resultant minimum spanning tree and I push them in the tree. That's easy. Nothing great done. Right. So let's start. Sorry. Right, and then I got weights are essential in this situation. Now d, and d dot x equal to x, d dot y is equals to y. Okay, we got g dot push back make pair w comma d. Oh, so good. And then I want something of d dot y is equal to x and d dot x is equal to y, and I got g dot push back make pair w comma d, right? So I'm essentially making a undirected graph. So let's just call, okay, I should know the number of vertices also. So I'll have do that. So now I'll call the reset and I'll say that max p plus 1 because it will go till n minus 1 if you look at this carefully, right? So that is done, that is done. So now I will call k g comma m, and then there will be a vector iterator it is equal to m dot begin for it is not m dot end, sorry, my fault, it plus plus, right? Okay, so this will be from x to y, c out star it dot second dot x to star it dot second dot y and the weight is this arrow need not be there. The weight will be star it dot first, right? Yeah. See, this is my minimum spanning tree. From 1 to 2, 1 to 3, 4 to 6, 6 to 5, and 2 to 4. Every vertex is visited from 1 to 6. There are 7 vertices. Every one is visited. And this is the minimum spanning tree, and you can just output the sum also. If you want to, I'll just output this from here. Sum is 7. 1, 2, 3, 4, and plus 3 is 7. Right. Let's take another sample if we can. See how this works out. See, the weights are the equal, so I don't think we should take it. Let's take something where the weights are not equal. I got all the examples with the weights equal only. This was the only one. So we can take this one, 8 1. Let's see what the answer should be. Just take this one, the last one. The answer is 5 0 to 1 1 to 2 2 to 3 1 to 5 1 to 4. So yeah, so this is all. This is the minimum spanning tree. Thank you.